So hello everyone. Now today we move on to solve the selected problem of the chapter 17, the power of point, from the AoPS Volume 1. So let's start with the question number 296. So in the diagram, okay, let's draw a diagram here. Yeah. Okay, so we have a chord of the CD, and the EB bisect the CD midpoint. The EB bisect the chord CD, and the C is the midpoint of AD. So this is the AD. Then we want to connect the AB and intersect with the circle at G. So we want to solve the GBX is X if AB is 16, right? So 16 minus X. And if EF, okay, I'm sorry, this point is F. If EF is 4 and the FB is 6. Okay, so let's using the power of point on the F, okay? On the circle means the EF times the FB is equal to, because these are the same, right? So let's parameterize, this is the A and this is the A, right? Equals to the CF times FD. So we know the A square is 24. Then we can solve the A is 2 root 6. So this is the 2 root 6. This is the 2 root 6. And also AC is the, C is the midpoint of AD, right? So this is the 4 root 6. Now we can solve it, right? So the power point of the A means the AC times AD is equal to the AG times AB, right? So we have an equation. So AC and AD we know, right? It's this one, and the 8 of the root 6, right? Is equal to AG is 16 minus X. AB is 16, right? So now we can see 16 minus X is equal to the 12. So we solve the X equals to 4. Okay, so do parameterize your diagram, okay, and to reduce all the unknowns and set up equations, then you can solve it. Problem, oh my god, problem 297. So the two tangents are drawn to a circle from exterior point A. We have a circle O. From exterior point A, we can draw two tangents. Let's see, this is A, B, C. Right, they touch BC respectively. Then a third tangent intersect AB at P. Another tangent intersect AB at P and AC at R, and touching this one at Q. So PQR is a tangent line, right? So if AB is equal to 20, what is the perimeter of the APR? This is a very important result, okay? So you can see from the point P, the PB and PQ are the tangent, right? And from point R, the RQ and RC are the tangent, right? So we know if this is the X, this is the X, right? If this is the Y, so this is the Y, right? So then you can see the perimeter of the APR is equal to the AP plus AR plus the X plus the Y, right? The AP plus X is AB, right? The AR plus Y is AC, right? Because I mean the AC and the AB and the AC are both tangent lines, right? So they are equal. If they are equal, means this one is 40, right? So next, a circle is inscribed in a triangle with the three sides. Okay, so we have the triangle ABC, and we have the three sides is 8 and 13 and 17. Okay, then a circle is inscribed. That means we have the in center here. Okay, so we have the in center. Okay, now we want to let the segment on the circle made by the tangency be the R. So this is the one of the R, the other called S, right? So by the tangency, okay, so this is called the DEF, okay? So we know the AE, if you're not familiar, let me give you the circle here, okay? By the tangency, okay, the AF and AE are both tangent to this circle, right? So if by the tangency, you should be very familiar with this, okay? This equal this. This equal this. And this equal this, okay? So you can see this is the R, right? So 2R is equal to, the 2R is equal to the AB and the AC plus AC. Take out the cyan one, take out the blue, green one, right? So it's AB plus AC, right? Take out this color and this color minus BC. So 8 plus 13 minus 17 is equal to 4, right? So now you know the R is 2, right? Once you know the R is 2, S is 6, right? Then you can solve the R over S is 1, 2, 3. Okay, so problem 299. So in this figure, we have a circle. Okay, then the circle O, then AB is the tangent line. AB ADOE is a straight line. Okay, so ADOE is a straight line, right? And the AB is this is the tangent line AB. AB is perpendicular to BC, right? Because AB is perpendicular to BC, so you know this passing the the BOC is parsing this one, right? You can see this intersect as O, so that means AB is a tangent line, okay? Because this is 90 degrees, this must be tangent line, so that's why the AP is equal to AD. So AD is here, then AP is equal to AD, and the AB has a length twice as the radius, okay? So we know AB has the length of the, let's parameterize, okay? This is the R, this is the R, this is the R, and if AP and AD is the X, this is the 2R minus X, right? We want to show the AP square is equal to the PB times the AB. Okay, let's see what is the PB times AB, okay? So PB times AB is equal to 2R times the 2R minus X. Okay, so we want to prove that X squared is equal to this, right? So we have a right triangle ABO, right? Let's apply some Pythagorean, okay? So we know that AB squared plus the BO squared is equal to the AO squared, right? So that means the 2R bracket square plus the R square is equal to X plus R bracket square. So from here we can solve is the X square plus the 2RX, okay? That minus the is equal to the 4R square. Okay, so what's this? PB times AB. So this one equal, this one is equal to 4R squared minus the 2RX. Okay, so now we get from here we can get X squared is equal to 4R squared minus 2RX, right? This side is equal to PB times AB. That's this one, right? What is the X squared? Is X squared equal to AP squared? Yes. See, X squared is equal to AP squared. Done. Right? So don't be scared. You just need to parameterize your figure and to see the rest of the work is like algebraic manipulation. Question number 300. Okay. So we want to find the area inscribed circle of the inscribed circle of a triangle with the 3 sides. So if we know the 3 sides is 20, 21, 29, we want to find the area of the inscribed circle. If you want to find the area of the inscribed circle, you need to know the radius, right? So how to know the radius? Okay, so you know the radius of the, we can cut in this triangle into 3 pieces, right? So first piece, second piece, and third piece, right? So the 3 pieces are half of the 21 times R, half of the 20 times R, and the half of the 29 times R. So in together, you know the triangle's area is equal to S times R, where S is half of the perimeter. Is 10 plus the 25 is equal to 35, right? And you also know the triangle from the Heron's formula, right? You know the triangle ABC is also equal to the S minus A, S minus B, S minus C, right? So the S is 35, right? S minus A is 35 minus 20 is 15. S minus B is 35 minus 21 is 14. S minus C is 35 minus 29 equals 6. Right, so let's see, it's the 35 is 5 and 7, right? 15 is 5 and 3. 14 is 7 and 2. And 6 is 3 and 2. Now you can see I have 2, 5, 2, 7, 2, 3, 2, 2, right? So it's a 5, 7, 3, 2. Then it is 210. This is 210, right? So you can go solve the R. So 35 times R is 210. Then R is what? So this is the 30. This is 5. So R is 6. Then the area of the circle is pi R square is pi times 6 square is 36 pi. The question number 301, okay? So in the disjoining figure, okay, so let's see. So we have a circle of the O. Okay, we have the AB is tangent to the circle. We have AB is tangent to the circle. And we have a point CD here. We have a point CD here. Now what we know is the CD here. We know the BC equals CD equals 3. And we know the OD equals to 2. AB equals to 6. Okay, so because AB is the tangent line, we want to use the power point on the B, right? So, and we normally when we do the chord, this BC, D. Let's see, this is the P, this is the M. Okay, so we know the power point of the B. We have the AB of the square is equal to BC times the PB, right? So we know the 36 is equal to 3 times the, we have this part is 6, right? Is 6 plus the PD. So we can solve the PD is equal to 12 minus 6 is 6. So we know the PD is 6, right? So we know the chord PC is 9. Once we know the chord PC is 9, because this is 90 degrees, from this one we'll always do a perpendicular because M is the midpoint. So we know it's 9 over 2, right? So this 6 over 2 is 3 over 2. Now it's easy. Okay, we can use the triangle MDO. So MDO is a right triangle, right? So we can see the MO is equal to the 2 square minus 3 over 2 of the square, right? And once you solve the MO, so the other right triangle is the MCO, right? So now you see the R square will be equal to the MO of the square plus the 9 over 2 of the square. Okay, so I leave all the calculation to you guys. It's root 22. Okay, so now the question number 302. So we want to prove if the quadrilateral ABCD is also diagonal and circumscribed around a circle. So if we have a quadrilateral is circumscribed around a circle, okay, let's see, this touching point are the these are A, B, C, D, then E, F, G, H. Okay, then we connected the diagonals. Okay, then this is 90 degrees. I still let you to see the where this one results we did before is very important. Okay, if also diagonal still remember in the quadrilateral, we mean the AB square plus the CD square is equal to the AD square plus the BC square. Okay, so from the also diagonal, we can have this. So this is no, right? Okay, then the next one is we want to prove the AB times CD, right? AB times CD is equal to AD times BC, right? So this is a big if, okay? If we know this, right? Did you see it's very familiar, and we can see if we have this, then what we have is we want to have the AB plus CD of the square is equal to AD plus BC of the square. So that means that if we can prove this, we can also prove this one, right? By combining with this. Now let's see. ABCD, ADBC. Okay, let's parameterize. So this is the tangent line, right? M, N, N, P, P, Q, and Q. Okay, so the AB plus CD is equal to the M plus N plus P plus Q. Did you see it? Then exactly is the same as the AD plus BC is also M plus N plus P plus Q. Now we prove this, and we can go back to prove that. So yeah, that's it about the selected problem for this chapter. Thanks a lot. Bye bye.